Morning. My topic is about depth first search. Before knowing depth first search, we must know what is graph traverser. Graph traverser is a technique used for searching a vertex in a graph. It's also used to decide the order of vertices to be visited in a search process. There are two types of graph traversers: DFS, BFS, depth first search and breadth first search. We know that graph traverser uses the order of vertices and the searching of vertices. So the graph traverser uses a unique method. Depth first search uses stacked data and the breadth first search uses queue data structure. And the depth first search uses last in first out. And the breadth first search uses first in first out. Now let us see the depth first search in a brief manner. The depth first search of a graph produces a spanning tree. What is meant by spanning tree? The spanning tree is a graph without loops. We use a stacked data structure with the max size of total number of vertices in a graph to implement DES of a graph. What does it means by the number of stack is equal to number of vertices. How much stack data space is available is equal to the number of vertices. Now let us see the algorithm. Step 1. Define a stack of a size total number of vertices in a graph. First in the verse, let us see. First we have to define a stack for total number of size. If it has 3 stacks, there must be 3 stack. 3 vertices means it must have 3 stack. Step 2. Select any vertices as a starting point for the traverser. Visit that vertex and push it in. We can start any starting point. And for step 2 algorithm, we can start any point. We can start a point traverser from any point of a vertices. I start from A, next B. Step 3. Visit any one of the adjacent vertex of a vertex which is at the top of the stack, which is not visited, and push it on the stack. It means if there is a stack already inserted if there is a vertex already inserted in a stack, the next element is pushed above the stack. That is step 3. Step 4. Repeat step 3 until there is no new vertex to be visited from a vertex on the top of the stack. We must repeat the step 3 until it fulls. When there is no new vertex to be visited, then use backtracking. Backtracking means popping one vertex from the stack. Example. If there is a element here, if it travels like here, A to B and B to C, now if it wants to travel to B, if it travels from A to B, B to C, if we want, there is no other vertex, so we must use backtracking. While backtracking, the C element is popped out and returns D. Now the vertex will be A, B, D. Step 6. Repeat step 3, 4, 5 until the stack becomes empty. When the stack becomes empty, then produce the final spanning tree by removing unused edges from the graph. Spanning tree, we know that spanning tree means non-looped graph. It will produce a final structure. Let me show you an example. Here is a sum which we derive. Step 1. On the first step, we can start at any vertex and we travel first to B for using alphabetical order A. On next step, after starting point, the next vertices should be pushed on the top of the stack. On step 3, it continues A, B, C and push, and the vertices C, it pushes the vertices into a stack above B, and next step it pushes the vertices E. On the step 5, E is popped into the stack. D is popped into the stack. On the step 6, after D is popped, there is no more vertex to be popped in. So we use backtracking. Backtracking means reversing the process and taking a element from the stack. So we have C, E, D. The D element is popped out and F is popped in at the place of D, and the next element after the F is popped in, G is popped in. C, E, G. After G there is no more vertex to be present. There is no more vertex to be popped in from the stack. So we must empty the stack. By finally doing the backtracking, we can get a spanning tree. In the final, after using backtracking from all the objects, we can get a final spanning tree. Thank you.